Let's make a closer look at convergent and divergent situation. We know that convergent is the pile up of air above any region, while the divergent is the opposite, that is spreading out of air above some region. So convergent and divergent of air may result from changing in wind direction and changing in wind speed. So convergence occur when moving air is funneled into an area, much in the way that we can make a similitude with the car converge when they enter a crowded freeway, and divergence occur when moving air is spread apart, so much as car speed out when a congested two-lane freeway that is becoming a three-lane freeway. So the more is spreading apart and speeding up. So on an upper level chart, these types of convergent, also we call it confluence. So confluence occur when contour lines moves closer towards as a steady wind flow parallel to them, and it's the same way the type of the divergent we also call is diffluence, and this diffluence occur when the contour lines moves apart as a steady wind flow parallel to them. So if you are not looking at this picture, that the air is blowing, the area converts, and it is lying, the surface anticyclone is H, whereas the below area divergent lies the surface mid-latitude cyclonic storm, that is indicating as L. So converging or convergent and divergent, that is also occurring result of change in wind speed. So wind speed, this speed convergent occur when the wind slow down as it moves along, and whereas the speed divergent occur when the wind speed actually speed up. So we can grasp this with the relationship with something that a molecule, air molecules are marching in a band. So if you are looking at over here, this picture illustrating how the types of convergent and divergent can occur in the upper troposphere. The upper air chart shows a trough and two ridges. We know that trough and ridge, trough is a low pressure system, ridge is a high pressure system. So when trough is creating, we are having a converging slow motion air that converging, and when the ridge is happening, we know that the diverging air will happen. But that is the technical things, that a trough and two ridges with evenly spaced contour line. Notice that even though the contour are evenly spaced, the wind blow faster in the ridge than they do in the trough. That's mean when the wind is coming from the high speedy wind is coming from ridge and creating a trough, that wind speed actually going down, slowing down. On the other hand, when the slow motion trough, from trough wind is going towards the ridge, that's mean the wind speed is actually increasing. So as the faster flow air moves away from the ridge and approaches the slower moving air in the trough, the air piles up, and this piles up produce converging air circulation or convergent. So on the other hand, if you are looking at where the slower moving air in the trough approaches the faster moving air in the ridges, the air is speed up actually, and this speed up produce a divergent airflow. So most of the time you will see over the mid latitude cyclonic form that likely location upper level converging air is to the left or the west side of the upper trough, and most likely location for diverging air is to the right or east side of the upper trough. So the divergence and convergence are very important to understand the mid-latitude cyclonic form, and we know that upper level and the surface level wind circulation that has to be opposite to sustain a divergent or a convergent flow or any kinds of cyclonic movement that we know of.